Welcome back to another video. In today's video, we're going to be looking at the topic isotopes, right? And the objectives for today's video, we're going to be defining what are isotopes. We also are going to prove that elements have isotopes, and possibly we're going to be looking at the uses of some radioactive isotopes. Now, this is normally a topic that persons tend to have difficulty with as it relates to chemistry. Now, a quick definition for isotopes, right? Isotopes are different atoms of an element that have the same number of protons and different number of neutrons. And in most books, you will see them have two definitions as it relates to isotopes. I'm going to give you the next definition in a few. Now, bear in mind that it is very much important that you know the difference between atomic number as well as neutron number. If you're not sure about the difference between two, you can look in our previous video, right? It is in the top right of the screen. Now, another definition of isotopes is that they have what we deem as the same atomic number, right, but different neutron number. Because remember, atomic number, in our previous video, atomic number tells you the amount of protons, right, and neutron number tells you the amount of neutrons. So in some books, you will see them saying the same atomic number, and I'm gonna be doing an example in a few minutes. Remember, if it is that you're having challenges with the subject, you can reach out to us, right, to get free customized worksheets, as well as you can also get tutors. That's the definition of isotopes. Now we're going to be moving on to objective 2. We're going to prove that elements have isotopes. And common examples, right, especially the one that we're going to be looking at in a few minutes. One example, first one is carbon, and the possible isotopes normally have carbon 12, which is a naturally occurring one, carbon 13, and carbon 14. Now we're going to prove that they are indeed isotopes based on the definitions that we outlined previously. So right, remember that the mass number, when you're writing isotopes, normally they write the symbol with the mass number. So in this case, it's carbon 12. This case is carbon 13. And here it's carbon 14. So they write the mass number with each isotope. So the common atomic number, right, or the proton number is 6. That's the atomic number of carbon. Previously in our video, we outlined that N would be equal to A minus Z. So therefore, it would be 12 minus 6 equal to 6. Moving on now to carbon 13, which is the next isotope. The mass number for this isotope would be 13, and then the atomic number would be 6. Using the same formula here, it would be 13 minus 6, which would give us 7. So I hope that we all are seeing the trend here. We are realizing that they have different mass numbers, right, but same atomic number. They have different neutron, right, and the same amount of proton. So let's move on to the final one. This one is 14 and 6. Right, so this would be 14 minus 6, which would give us 8. So that would give us 8. So we're going to be moving on now to hydrogen. Now, again, remember the elements are important in terms of the symbol. So the symbol for hydrogen is H. The common ones, possibly 2, 3 isotopes, you would see hydrogen 1, 2, and hydrogen 3. Now, in some books, you will see them naming these 3 isotopes, right, which would be hydrogen 1 is also known as protium, so it's important that you know it as well. Then you have deuterium, right, and it's important that you practice, because, right, if you don't practice, then you're gonna have challenges in the subject. You have tritium. Now again, we want to prove that these are indeed isotopes. For hydrogen 1, remember the atomic number and the mass number, so it's 1 and 1. And if it is that you're having challenges knowing the mass number and the atomic number, then draw for the periodic table. So it's, in this case, it's 1 minus 1, which would be equal to 0. So we don't have any neutron present in hydrogen 1. Moving on now to hydrogen 2, which would be 2 minus 1 give us 1, right? And then tritium, hydrogen 3, which would be 3 minus 1, which would give us 2. So these are the difference, and we should be seeing that as well. Others that you can practice, right? You have chlorine 35 and you also have chlorine 37. So you can practice those. So chlorine 35, right? Chlorine 37. So if you're at this part of the video, right, you can pause the video and you can work out these, which would be chlorine 37 and also chlorine 35. Common exam topics that we normally see as well under isotopes, right? You normally see radioactive isotopes, right? And they normally ask students to state the uses of radioactive isotopes. So we're going to be closing off this video with some of the uses of radioactive isotopes. Now the idea is that as it relates to radioactive isotopes, their nuclei, the nuclei is unstable, right? And it undergoes radioactive decay, right? And in radioactive decay, they're gonna eject small particles, right? And the reason why they eject these particles is that they want to become stable. Commonly, even though it's a topic in physics, you would normally see half-life being mentioned as it relates to radioactive isotopes. Now, what is half-life? This is the time taken for half of the nuclei in a sample of radioactive isotopes to undergo radioactive decay, right? And if you have a graph, right, because in our next video or in our coming videos, right, you will know more about half-life. Because if you're doing science, remember that you need to know how to plot graphs. So in terms of the uses, right, as it relates to radioactive isotopes, and this is a common disease that is currently taking over the world, we have cancer. Radioactive isotopes, they are normally used to treat cancer, right? And you know, as it relates to chemotherapy, right, this is where they would use a beam of radiation of isotopes to burn out cancer cells and so on. You have common ones, right, as it relates to cobalt, stuff like that. So you can also do further research on that. Also, another use would be energy generation, right? In terms of isotopes, they are used to power nuclear plants. Believe it or not, some countries also use radioactive isotopes to make atomic bombs, nuclear bombs, uranium. Those are common elements that are essential as it relates to energy generation, right? Or even atomic bombs and so on. We're gonna be doing a quick revision right before we close this video, because this is the end of our final objective. All right, in reviewing, remember that as it relates to isotopes, right, they have same protons but different neutrons, right? And commonly, you would see two definitions as it relates to isotopes. You would see them saying that these are atoms of a single element that have the same atomic number but different neutron number. And we prove that in this example where you have carbon 12, 13, and 14, right? And if you're supposed to look at the bottom here, you should see the trend where the mass number up top that varies, and at the bottom the atomic number remains the same. The amount of neutrons, right, they are different. So if you're working with definition 1, which is this definition, or definition 2, right, just know that remember that you should be able to prove that the definition is indeed correct. Another typical example is hydrogen, and there are 3 possible isotopes. We have protium, deuterium, and tritium, right? And we did this here, which would be hydrogen 1, 2, and 3. So remember that as it relates to radioactive isotopes, they have unstable nuclei, right? And they undergo radioactive decay. You would learn about beta, gamma, alpha, right? Mostly in physics, right? Even though it's a topic in chemistry, but you would learn mostly about that in physics. right? They eject certain amount of particles, and the reason why they would eject particles is that they want to have some form of stability. Now, common uses, we talk about cancer treatment, right? They would use beam of radiation to burn out cancer cells, and also energy generation. They are used to power like nuclear stations or power plants. And remember that a lot of countries use isotopes to make atomic bomb, nuclear bomb. So nonetheless, if you have made it to the end of the video, don't forget to like, share, and subscribe. And also remember to reach out to us for free PDFs, free study guide. Also remember to watch the video that you're seeing on the top right of the screen. Until next time, peace.